one of my other videos, I mentioned a common ancestor between dragons that got me thinking. If dragons were real, what would their common ancestor be? Would a wyvern and a worm have the same lineage? Or come from different branches of evolution? So I got to researching, and wow, there are a lot of dinosaurs. But before we dive into our prehistoric candidates, let's discuss which dragons we'll be tracking down to their ancestral roots. For this project, we'll be examining wyverns, worms, Chinese dragons, drakes, classic dragons, and cockatrices. Each of these dragons are distinct enough that they might have a different ancestor, or in some cases, I found dinosaurs that were just too perfect to ignore. Number 1. The worm. Let's start off with the easiest one, the worm. About 60 million years ago, the Titanoboa slithered across the Earth. This massive snake could reach 42 feet or 13 meters long as an adult. It primarily lived in swamps, with fossils found in parts of Colombia. Despite some artistic depictions of Titanoboas fighting sharks, it primarily ate fish and other vertebrates. If worms were real, they'd definitely be part of the Titanoboa family. The similarities are uncanny. The only major difference is their scales. Titanoboas, like their closest relatives anacondas and boas, likely had smooth, small scales. Worms, however, have large, jagged scales that are common in dragons. Still, it's safe to say that worms could have evolved from a Titanoboa ancestor. Wyverns. Now you might look at this chart and go, wow, there are so many dinosaurs that could become wyverns. Doesn't that make it easier? Wrong. There are so many potential candidates, so I have to sit down and sift through each one. We're looking for a carnivore that walks on 2 legs that can also fly, has sharp teeth, and sharp claws. So let's start with theropods. These bipedal dinosaurs had short forearms and bird-like feet. If we take a step further, we find 2 interesting subgroups. Coelurosaurs, which include raptors, and Carnosauruses, which include large predators like T-Rexes. Many of these dinosaurs had sharp teeth and even hollow bones. Why are hollow bones a good thing? Well, in order for a bird to fly, they have to be very light. So having hollow bones helps to aid birds in their flight. But most of them, despite having feathers, couldn't fly, or could only glide, so they're out. Alright, we've gotten rid of a large number of our contestants, so what's left? Enter the Dimorphodon. This creature is practically a wyvern already. It even walks on its wings like a wyvern tends to do. Dimorphodon was only 3 feet or 1 meter long, but was a carnivore. Their teeth have led scientists to believe this dinosaur hunted fish. Some scientists even believe this dinosaur might have had waterproof fur. Fur on a dinosaur! But it's not confirmed. The only thing holding the Dimorphodon back is its size. If it evolved to be just a few dozen feet longer, we'd have ourselves a full-fledged wyvern. This is easily the best match so far. Hopefully, the next one will be just as perfect. Drake. Drakes are tricky because they're 4-legged carnivore reptiles, which are surprisingly rare. One of the best matches at first glance is Inotransavia, a large predatory quadrupedal dinosaur discovered in Russia. But there's one major problem. It's not a dinosaur. It's actually a mammal-like reptile that lived before large dinosaurs existed, so unfortunately it's disqualified. According to Ask Me Media Filter, strictly speaking, there are no known carnivore dinosaurs who walk on 4 legs. But that's not gonna stop me. I looked, and finally I found something. Spinosaurus is famous for its appearance in Jurassic Park, and the sail-like structure on its back. It's thought this sail is used for social display. This dinosaur lives in North America and measures between 39 to 59 feet, or 12 to 18 meters long. Scientists still debate on whether this dinosaur is bipedal or quadrupedal, giving me just enough leeway to claim that it was likely quadrupedal at times. It's not hard to imagine the sail on their back could evolve out of fashion. As time goes on, the Spino's evolution favors larger, more muscular limbs to help it catch prey. Over time, you have a drake. What do you think? Is the Spinosaurus the most fitting for the drake? Or is there another dinosaur I should have mentioned that you think would make for a much better drake? Let me know if I missed something. Cockatrice. The cockatrice, despite looking like a chicken, has many feathered reptile relatives to choose from. For example, the Dromaeosauridae family. This family consists of small feathered dinosaurs, and even members of the raptor family. Yep, that raptor. But unlike Jurassic Park, scientists now believe raptors might have had feathers. In fact, it's believed that a lot of dinosaurs had feathers. So which one is the best for cockatrice? Well, none. Cockatrices are typically depicted with beaks, while Dromaeosauridae had teeth. That means they're out. Next, let's look at the Therizinosaurus. This dinosaur looks like a giant turkey, but after closer inspection, I noticed that their beak had teeth. Disqualified. Then I thought, what about birds? Birds aren't dinosaurs, right? Well, according to Life Science, birds are dinosaurs. Okay, technically, modern birds aren't dinosaurs, but the birds we know today evolved from dinosaurs. They survived extinction and became the delicious chicken nuggets in your Happy Meal. Talk about a downgrade. Let's start with probably the most popular ancient bird, the terror bird. This bird could grow up to 10 feet tall and weigh 1,000 pounds. They were apex predators, meaning you would not want to run into this massive bird. But surprisingly, this bird is not a dinosaur. They came from the Cenozoic era, meaning they're disqualified. Okay, well, if terror birds are out, what's left? Well, Oviraptor, of course. Aside from being useless in ARK, this dinosaur has a beak. Hooray! They ate eggs and small animals, which aligns perfectly with serpents and chickens. Yep, chickens. There are reports of cannibal chickens, so given the opportunity, they'd eat eggs. Even the chickens know that they're delicious. Evidence from fossilized remains and related species indicate that oviraptors had a covering of feathers, adding to their bird-like appearance. There is no doubt that this is our dinosaur. Perhaps their prey adapts to be stronger, forcing the oviraptor to evolve to be bigger and fly, creating our cockatrice. Wow, that was a long one. If you made it this far in the video, remember to like and subscribe so I can make more crazy videos. Chinese dragon. I expected finding an ancestor for the Chinese dragon would be impossible. Four-legged reptiles with long serpent bodies are rare. But then I found Gnathosaurus. If you look at this dinosaur, you might notice it looks like a Nile lizard. But this lizard only grew to be about 10 feet, just barely longer than the largest living lizard alive, the Komodo dragon. It's believed that this dinosaur lived on the coast and would dive into the sea to catch prey. It had webbed feet and a thick tail for swimming. Evidence suggests that this dinosaur gave birth to live young. Fossils of Gnathosaurus have been found in Europe, North America, and China. Pretty fitting that the Chinese dragon's ancestor came from China. The biggest problem? Chinese dragons are often depicted with manes, and there's no evidence that Gnathosaurus had fur. But since hair and fur doesn't fossilize well, it's possible they had some form of primitive fuzz that later evolved into the dragon's iconic mane. Classic dragons. Finally, the classic North American dragon. We need a reptilian ancestor with 4 legs, wings, claws, and fangs. Easy, right? Not at all. I already discussed the difficulty in finding a 4-legged dinosaur, but it's only made harder by the fact that this dinosaur needs to fly, or reasonably be able to evolve to be able to fly. A flying creature with more than 2 legs. Well, what about insects? Nope, I'm strictly sticking to reptiles since the odds of an insect or another species evolving into a reptile is very low. No insects. So what about flying reptiles? Wait, what do you mean flying reptiles? You mean dinosaurs? This is what I mean. This is Dracovolans, the real-life flying dragon of Southeast Asia. This lizard can glide using wing-like flaps along its ribs. This is not a dinosaur, but it's the closest living relative to our mythical dragon. He belongs to the Amidae lizard genus, but if we track back Dracovolans far enough, we find the Microraptorans. Some scientists believe they've shared a distant evolutionary link to gliding lizards, like Dracovolans. I know this dinosaur looks perfect for evolving into Quetzalcoatl's dragon, but this is actually our classic dragon ancestor. If they continued evolving into larger, more powerful gliders, who's to say they couldn't actually become fire-breathing winged dragons? So what do you think? Do you think that the Microraptorans are the best ancestor for our dragon? Or is there a more fitting dinosaur? Let me know your theories in the comments. And if you have any crazy video ideas, tell me. I might just make it happen. Until next time, keep exploring history one creature at a time. So having hollow bones helps aids in we find the Microraptor anus.